This conference will now be recorded.
Plus simple de parler en français que lui.
Oui, oui. Je comprends. Ouais. Okay, hello everyone. So we were trying to wait for our classmate, but anyway, she's coming pretty soon, so we might start yet. So the purpose of today's class. Can you shut the door, please? Maybe because I don't want to. Thank you. The purpose of today's class and for the next 4 days will be about business intelligence. So we'll still be talking about databases a lot actually, but you guys need to understand that we are going to cover a whole different subject, okay, from now, because yesterday we talked about databases, okay, Oracle databases in particular, but in a more general way, we talked about the databases, how they work, what are the files in them. So just know that what we discussed about Oracle yesterday has a lot of similarities with SQL Server, MySQL. They do have differences actually, but the main talking we had to yesterday can be applied to them. So like maybe table spaces. When we talk about data block, actually on SQL Server, you don't talk about data block but page. So this is just a different way of speaking, but actually the concept is the same. So you might maybe use this knowledge over other RDBMS. And so today we will be talking about still about databases, but actually we're going to talk about what actually the business intelligence is. So we're going to talk about business intelligence, and we are going to cover a lot of subject around it, technical subjects, which will allow us to talk about a new kind of database, still a SQL database with tables that have relation between them, but we will see that the way that we are going to modelize the database and why we do modelize it this way has some purpose towards the business intelligence problem. Okay, so first thing, what is business intelligence? So business intelligence is actually a domain that will help businesses take better decisions. Basically, the smallest, the shortest definition could be this, but this is way too vague. We need to have some more details. So basically, how do we help businesses take better decisions? Actually, a lot of businesses, if not all, do have more or less a lot of data inside of the company, but sometimes the data can be retrieved in one particular space, and so it makes the analysis easier. But sometimes the data can be really I would say spread out everywhere in different files, different databases, and sometimes when you want to do a full analysis, when you want to do a good analysis of your own data, you need to kind of correlate data between each other. You need to make sure that you've got the whole picture. If you can kind of cross over data from one source to another, you would like to do so. So in this situation, the purpose is to make sure that every data we have about the company itself can be used and can be easily used. So in this situation, we are going to use something that is called the ETL. So the ETL stands for extract, transform, and load. This is a tool, a graphical tool that will let us do something like this. These are the data sources, so it could be Excels, could be databases, whatever. And these data need to actually be brought through the ETL into one big SQL database that is actually called a data warehouse, which often is spelled DWH. So why do we do so? Because one of the first purpose of the business intelligence, so one of the main purpose of business intelligence is to make sure that we can gather all of the data we need in order to do good analysis. So thanks to the ETL, we are going to get the data from every sources and put them into a data warehouse. But we are not going to do so like just extract and load. ETL stands for extract, transform, and load. And the transform part is the most important one and the biggest one, because in this step, we're going to apply a lot of, I could say, modifications over the data, but it's not actually modification. It's more like cleaning and I don't have all the words in English, but actually this is about sorting and not maybe filtering some data, maybe aggregating data. So we've got a lot of stuff to do about all over the data, and basically the data from the source could be somehow and in some way it could be wrong. So sometimes we could have bad types of data, sometimes we could have missing data, sometimes we could have duplicate data. So we have a lot of stuff to do thanks to the ETL to apply everything is needed to make the data clean and accessible in one big place. Yeah.
So ETL, you mentioned it's a graphical tool. So that was kind of surprising because I thought ETL was kind of a concept, but it sounds like it's an actual application that's been developed by somebody.
Yeah, basically you've got on the market, so I could show you, but I can give you the names. On the market, you've got a lot of actors that actually propose, provide an ETL. So you've got Microsoft with SSIS, and more recently they got Azure Data Data Factory, I guess. I need to make sure. You've got Informatica, you've got Talend, you've got Pentao, you've got DataStage. So you've got a lot of actors on the market.
Orange 3? Have you heard of Orange 3?
Orange 3?
Yeah.
No, actually.
No, like I use the Anaconda distribution for Python,
okay.
And they always include this app called Orange 3, which is a graphical interface that does stuff like that.
Yeah, I'm pretty sure this is an ETL, I guess. So basically, yeah, I think that you, I clearly don't know all of the ETL on the market. I can give you the main ones, the best ones. I think the best ones, but actually there are a lot of them on the market. This is not a concept. I mean, this is actually a tool that you can make development on. And when I talk about development, I'm not talking about writing code. I'm talking about designing data flows that will help data goes from one source to a destination through different transformations, and we can do a lot of other stuff around it. So like, for example, on SSIS, we will see a lot about this. We design packages that will be kind of associated to one specific job. And in one package, I could say, first, I want to clean this table. Then I want to fill this table with data with a lot of transformations, and once I'm done, I want to send an email and then maybe send something to a FTP server. So you can do a lot of stuff thanks to the ETL. But the main purpose of the ETL is to make data goes from one source to a destination through a lot of transformations.
Would that mean that Power BI on some kind of definition is an ETL?
So basically, we are not going to cover the Power BI subject because we don't have time to. Yet I discussed with Sebastian, and we might do something about it. So I could give you actually a course about Power BI to make it clear, but I think it should be clear at the end of the course. Power BI is actually known by people as a data visualization tool. So it will be some kind of the end of the chain of the BI development. Okay, so you first integrate data, you analyze it, and then you can display it. But actually, Power BI is a way more powerful tool than we usually think. This is a whole BI tool that will let you get data from different sources, let you transform data, let you create measures over data, let you analyze data, and let you visualize data. So this is a very big tool, actually the best one on the self-service BI on the market. I will discuss this subject later. But Power BI is from Microsoft, but is not in the Microsoft suite. This on the Microsoft BI suite. This is more like complementary, or even maybe some kind of replacing sometime. Because with Power BI, we could do some whole BI project with Power BI. But we'll discuss this. So basically, to answer your question, Power BI does provide some kind of an ETL, which is called Power Query, that you can use with Excel. So basically, Power BI is just the combination of all of the add-in that went to Excel. So Power Query to modify data, Power Pivot to analyze data, and Power View, Power Maps to visualize data. Okay, so basically, Power BI does include an ETL, okay, but that will be less effective in some way and less, I would say, flexible to do some stuff than a classic ETL.
So maybe like the comparison between Microsoft SQL Server and Microsoft Access. It's kind of like not quite. It's a similar. It's the same concept, but not.
Yeah, if you wish, yeah. But I would say that if I'm, as far as I know, if I should be totally honest, I think that the Power BI ETL tool is kind of powerful, but is not as much as a classic ETL tool that is designed specifically for this kind of stuff. So like, for example, during the course, we will see how we are going to handle rows that should be included in your data warehouse. And so for this reason, we will try to do something like it's called the rejects. So we're going to say these rows, they are not going to be inserted into the data warehouse. We're going to reject them somewhere else. And as far as I know, you cannot simply handle rejects on Power BI, for example, and this is a huge stuff. So I think there are a lot of limitations actually, but you can actually a lot of projects only with Power BI and nothing else, because sometimes the project is not that big. Okay, but on big projects, I would say that Power BI is more likely to be the I would say the end of the chain, like the final visualization tool. Okay, so you can use it in different ways. Okay, so for the BI, we are going to use the ETL, and we are going to finally put all of the data into the data warehouse. But what's the purpose of doing so? Because as I told you, the purpose of business intelligence is to help businesses take better decisions. Here, okay, I'm just saying I'm taking all the data you need from the different sources you gave me, and don't forget about this, we're not going to do this one shot. We are going to design data flows that are going to run maybe every day, every night. So the purpose is to have actually refresh data every day, okay? But once you put everything with a good format, because you're going to, maybe change the type, change the way the data is written. Like for example, if we got male and female, we don't want to see 1 and 0, things like this. So we're going to kind of put everything in the same format. So we're going to make the data really clean. Once you've done so, if you want to say to the business guys that are going to analyze the data, so like what we call them the business analyst, these people, they are going to say, okay, we need to analyze data. Okay, guys, it's here. But for maybe 98% of these guys, they don't know about SQL. So they are not going to be able to query the database. So it's not sufficient. Once the data is available, you need to make them easily available. So that's why, if I make it my way, I would say you have two major ways to display the data. You could be using paginated reports. So basically, these are reports that can contain a lot of detailed data that you want to analyze. Like maybe I want to analyze something on a specific day on a specific product, maybe all the rows that are related to the sales of this product. So you want to have very specific reports. So we might discuss this difference later with what we can call dashboards. That will be more like big data analysis, not big data, sorry, not the good word, but macro analysis. Like we want to see a lot of information grouped in a very macro way, and so we want to have a big picture of the company. Okay, so like this, could have like this, could have some KPI. Okay, so we can have trends or things like this. This is more, so there is a real difference in the way that you display data from a paginated report and a dashboard. Okay, these are the two ways, but they are actually reports. And what you can do, what you can also do is to create, I don't know if some of you know about this, but what we can call an OLAP cube. Do you guys know about this? No? So this is pretty new. So we are not going to cover this during the course, but basically an OLAP cube is also, as the data warehouse, this is also a database, but that is strictly not the same than a classic database. So basically you won't be using SQL to query it. The data is not stored in tables, but actually stored in things like just basically measures and dimensions. So this is not the same way of storing data. Here we've got something that uses tables. Here we have got something that's going to use and interpret XML files, for example. So this is just not the same way of storing it. The purpose, just so you know, the purpose to have a cube is that when the cube is available, when you've got your guys here, let's say the business analysis here, okay? These guys, they ask questions about the business, so they want to understand. So they are going to use dashboards, paginated reports, and they're also going to use the cube, but not directly. They are going to actually use Excel to then analyze data. So thanks to Excel, they can connect to the cube and analyze data. The purpose of doing so is that they can do something they really like. It's called tablix. Maybe the tablix, pivot table, if you wish. I know there is different kind of wording, but basically something that is going to be a dynamic table. Like you can grab stuff on the right and say, I want to analyze this over this and over this, so you just pick whatever you want. So you call this a pivot table. Okay, so we got also in business intelligence, we can also call this a tablix. In French, this is called tableau croisé dynamique, and this is way longer. So yeah, I think the pivot table is a good wording here. Okay, so basically they can do whatever they want with the data that is available, which is a huge advantage for us and for them, I mean. So you've got, I would say, the whole picture. Yeah.
I know there are two basic models for BI, the multidimensional model and tabular model. Which of these are we focusing on? Is it tabular or multidimensional?
Okay, so basically you're talking about, so what your classmate is talking about is making kind of the situation a bit difficult for me, because basically I'm trying to explain to you the concepts of OLAP cubes. Okay, this is the way it was for a long time since they were created, like back in the 2000, I guess, very early 2000s. I would say that Actually, on Microsoft, you've got two kinds of cubes, if I can say so. You've got the multidimensional cubes, which is what I just show you here, and we've got another kind of, if we can say so, cubes that actually are not really cubes and that we call tabular models. Okay, so there are two kinds of this. Because the course is not about this actually, and we're actually going to do this during the course. We are only going to focus about this, okay? We don't have time to cover everything, okay? So we have stuff to do with this. So basically, I won't cover up the other subjects, but just know that basically, to get to this, we are going to work on the Microsoft BI suite. So it is made of the following. We've got SQL Server, which is basically the database. We've got SSIS, which is the okay. This is the cube, if I can say so, and this is the reporting. Okay, so just note I didn't talk about Power BI because I would say around it. Okay, not in the suite. And this is the DB, okay, the database. Okay, we are going to only work actually with this. Okay, SQL Server and SSIS. These are the two. Just know that actually on SSIS, sorry, you've got two kind of projects. We've got the multi-dimensional project, sorry for the writing again, multi-dimensional, and we've got the tabular model, such as table. And so these are different ways to create two kinds of cubes. Actually, the second one is not a cube, but because a lot of people people always associate SSIS to cubes for historical reason. So basically, we still talk about a cube, even though this is actually not a cube. But even Microsoft uses the term of cube, whether it is not. So just know that for this SSIS part, you could have either multidimensional or tabular. These are two kinds of projects. If we do have somehow during this year, we've got a course about Power BI, you would see that I would talk a bit about the tabular model, because Power BI and tabular model, they use the exact same engine database. So basically, this is something that is called in-memory VertiPack, and this is something that uses the same technology behind. Okay, so there is a lot of similarities between a tabular project and Power BI. So just so you know. So I'm not going to cover this subject because this is out of the scope, and the reporting part is based on SSRS. Okay, and we are going to only talk about SQL Server and SSIS. Okay, how are we going to develop this? We are going to use the following tools. So we're going to have SQL Server database. So everyone should have installed it, as I guessed yesterday. Then we're going to have two applications. I'm going to put them in, I don't know, in yellow. We've got SSMS, which is SQL Server Management Studio. And we've got Visual Studio SSDT, SQL Server Data Tools. Okay, these are the two applications we are going to finally use only these two applications, because SQL Server is just a service. So we are not going to use a service directly. We're going to use a service through an application. So we are going to use SSMS and Visual Studio to work with the database. Actually, the one we are going to use a lot is going to be Visual Studio, because we are going to design packages in SSIS, okay? But we are going to use SSMS to kind of administrate the database. Like if we want to create new database or new tables, or we want to verify the data we just integrated, we're going to check with SSMS. But basically, I would say that 10% of the time we're going to use SSMS, and the 90 other percent are going to be about only Visual Studio. Yeah?
What kind of coding language will we use in the SSD? Is it DI?
SSDT.
SSDT.
SQL Server Data Tools. So basically, pretty much known. I think we are not going to code pretty much anything. So we are going to, basically, this will going to be a very graphical tool. Like I've got some sources, I got some destination, I want to link them. So this is going pretty much it. We do have some code to do, but very simple code, like very, I would say, basic programmation. Like for example, if this is not an if, but something like this. What if the condition is true? What do? We want to try to find the rows that accept this condition. So very, very simple code, okay? And for the pretty much low code we are going to have, we're going to have a lot of functions that will help you really, really fast. So
But is it C# or?
I think this is kind of related to C#, but actually I don't really know the name of the coding actually, because I think this is kind of specific to SSIS. Man, this is really, really simple. We are not going to be big developers here, okay? We are not big coders, okay? We are going to have a very small amount of code to do, and very, very small. The purpose of an ETL actually is to be something really, really graphical, okay? And so we will discuss this subject later, but the purpose of doing so is that when someone goes after you in this project and sees what has been done, he needs to know pretty much easily what happened, what is going on, because this is mainly graphic, and not, you don't have to go into the code and understand this. So basically, you want to make your project as clear as possible. This is one of the main advantages of using an ETL over SQL, for example, because a lot of stuff we're going to do through the ETL could be actually done thanks to SQL. We could do so, okay? But we will see the reasons in the end why we can use packages on SSIS, why do we use SSIS actually, and why it can be very useful in the end, okay? No question? Okay, so before using the tool that we are going to do this afternoon, I need to make again some theoretical concepts clear to you. So basically, as data engineers, you should actually know about database modelization. You should normally know how to modelize a classic database that is going to be used for an application, that is going to be used for a website or whatever, okay? So basically, when you've got a classic database, I'm going to call it OLTP, you will see why after. Oops. OLTP, you will see why after, so OLTP. So basically, it could look like this. These are tables, if you wonder. Okay, this could be a modelization. This could be some kind of modelization of your database, right? So you could have a lot of joins like this, etc. Okay, this could be a classic database. Even if my question could be a bit vague, I think that what are we going to make sure when we design a database like this? What are we trying to make sure of, or we're trying to avoid maybe? Do you know this? No duplication of data, which is known as redundancy. Okay, we try to avoid redundancy. This is the main concept behind this. Okay, so for example, I don't know. For example, this could be we could have two tables, which are the table I don't know, customers, and the table country. And why did we choose to separate them? Because when you've got one entity, an employee is an entity, a customer is an entity, a country is an entity actually. When you know you've got multiple entities, you create basically one entity equals one table, okay? Why do we do so? Basically, just imagine a simple situation. You've got a customers table with a lot of information about the customers, the name, the last name, first name, etc., etc. And after this, you know that you've got to get information about the country, but not just the name of the country, the code of the country, the name of the country, the population of the country, the size of the country, the president of the country. So let's imagine together that we need to have 10 informations about the country, okay? When you do so, you want to split it into two different tables. But what if you don't split the country information into a country table? Why do you don't actually put all of this information inside of the customers table? It's simple. If you've got a customer table with, I don't know, you are a big company, you've got 5 million of rows, 5 million of customers, okay? And you've got, for example, 1 million of people that live in France, okay? The problem will be the following. If you've got 1 million people living in France as customers, and you put the information of the country in the customers table, you're going to have 1 million of rows that are going to have the same exact data for 10 columns, the 10 columns that are associated to the country, because the 1 million of them are in the same country. You're going to have the same information: FR, France, population 67 million, I guess, something like this, and the same information on the same column are going to repeat themselves as much as they are French customers. You got it? So you're going to actually repeat 10 times 1 million rows. So you're going to have actually 10 million redundant information. So this is not something you want to have, right? So the main reason we split the tables like this is because we want to make sure we are not going to have data redundancy. That clear for everyone? Yeah? So, but one thing people don't really actually think about every time, maybe what I just explained to you, maybe you already knew it, maybe you partly knew it, or maybe you just discovered it, but basically maybe I think everyone understands it. But something that a lot of people are missing about this is that there is a second advantage of having this modelization, and actually which is a consequence of having no redundancy, which is the fact that this is called, so this is something that is, I would say from a business intelligence perspective, this is called an OLTP system, which is OLTP, online transactional processing. Transactional, we discussed this subject yesterday. A transaction is modification over the data, right? So when we say this is an OLTP system, OLTP database, this is actually a database that is made for transactions. But why is it so? Because since you don't have redundancy, something people don't really realize is that it also have a big advantage, is that the transactions that will occur on the database will be quite fast. Why? Because again, if you put everything in one table, such as customers and country, tomorrow the population of France evolves and goes from 67 to 68. We need to change this information. Well, if you've got every information about the country inside of the customers table, it means that the country information is repeated 1 million times. So if you want to apply a small change, such as just change the population of the country, you're going to apply this change over 1 million rows. You got it? Whereas if you split data and you've got first here, we've got customers, and here we've got country, well, in this situation, you only have to update one row, and that will be sufficient. We're good about this? So these are the two reasons we split data, and this is why this kind of database is going to be really efficient thinking about transactional systems, right? So these databases are actually made to be able to sustain and to be able to resist a lot of different transactional queries all over the day, and maybe a lot of them, tens of them, every minute, every seconds. Okay, these are going to be microtransactions. They are going to be really, really fast, really small, but a lot and a big number of them. Okay, so that's the main purpose. But here is the problem. If you want to do analysis directly on this table, so let's just imagine that your business only has this database as information, as source of information. You could be willing to say, well, let's just do analysis and do some reports over this direct database. We are not going to create a new database. We are going to do everything inside of it. The problem is that if the volume goes up and up, actually, in the end, you're going to have a performance issue. What could be the performance issue in this database when you want to kind of access millions of rows and you want to analyze them? What could be the possible problem in here?
When you have to get an aggregated result, which is distributed over multiple things, to join those, it might create a execution. It can elongate the execution time.
Exactly. The joins will be the main reason why the queries will take longer. So basically, the queries should get to the end, but the more joins, the more rows, and the more time, basically. So here, exactly, the joins are going to kind of make the performance suffer. Okay, so this is the reason why we are not going to apply BI and do business analysis over a simple OLTP database. Instead of it, OLTP, online transactional processing, which differs from this. This is the classic modelization of a data warehouse. Which is actually known as an OLAP database, which is online analytical processing. The purpose of the first database is to allow and ensure that a lot of transactions will be done quite fast and easily. The purpose of the database is totally different, is to provide a way to analyze way faster the data. Okay, so up to you. So let's imagine here that in this model, it is a fact table. So it's going to be called a fact table, which contains fact. We will discuss the concept of fact just after. And this is called a dimension table, okay? And in this dimension table, we could have information such as, I don't know, maybe this is going to be, I don't know, here, this is going to be the sales. And here we've got the customers, the product, the date, and maybe here, I don't know, the geography, the country. Okay? So basically, what makes you think that this modelization would be better for analysis?
It's simpler.
Why is it simpler? What do you mean by simpler?
Well, you don't need to know SQL joins and stuff. It can be linked directly to some kind of SSIS.
I disagree. You need to do joins. These are 5 different tables. They are not the same table.
I thought you meant the sales as the connected data warehouse.
No. These, okay. These, sorry, maybe I'm not clear enough, but sorry. These are also tables, okay? Everything here is tables, and everything here is tables. This is just the modelization that will differ, okay? So what do you think is the reason this is going to be actually easier to query on, to do big select?
I think because it's segregated. Can you hear me?
Sorry?
I said because it's segregated, you are grouping data along different lines.
So the sales data, you have facts data, you have dimension data, maybe for data that is not recurring, that is not transactional in purpose. So I think the basic reason why it's better is because you have data segmented across different lines.
This is not a line subject, a row subject. This is more like the modelization. You talked about some kind of, you said segregated. What did you say as a word? The data is what did you say?
Yes, I said it's segregated across.
What do you mean by segregated?
That you are bucketing it, you are grouping it across the different use cases.
Okay, you're going a bit. I think what you're going to talk about is more like maybe I think would be more like the data mart. Maybe you are going to group data into different kind of businesses. Maybe this is what you're talking about. So this is not actually false, but just actually my question here. Yeah.
Does it have something to do with same primary key associated with the foreign keys of the table?
So basically, there are foreign keys from the fact table to the dimensions, such as there are foreign keys here.
Same primary key associated with the different foreign keys?
Both of these models will have foreign keys. Actually, my question is quite simple. We discussed something before, and we gave reasons why this is good and why this is not good. Yeah, take it. So what would be the reason here? What would be the reason here?
Can I say something? Yeah, I think the main reason would have been we've done some pre-calculations or aggregated data, and we're not computing too much. And your dimensions would be your slicing over the facts table, which would make your query less of join. And
I think I didn't hear everything, but I think one word is missing from everyone here. This is one big word.
What is the structural difference between these two? They look similar to me.
They don't actually look similar. Even the color, I mean, no, not the color, but actually, oops.
So what I said was we have done some pre-aggregation before now.
Don't talk about aggregation right now. We will discuss the aggregation subject after. You're totally right about this, but actually, we could talk about some aggregation. Actually, we could do so, but in this situation, this should not be aggregation. You will see why. Your classmate told me that he thinks that I removed a bunch of tables from my model. Actually, I'm not telling you here that this becomes this, okay? Maybe this database could be one of the sources, but don't forget we could also have some Excel files that could be also added, okay? So I'm not trying to say that these databases are the same one in the end. No, I'm just giving you two different examples. One, let's say this one is about, I don't know, phone calls, and you've got a lot of information, and this one is about sales. I'm not trying to make a comparison of all the data, but the way it is modelized. The one big word that is missing from everyone here is join. Here in this situation, you've got less join to do to analyze the data. So for example, if I do some kind of similarities here, let's imagine this model is also about sales and etc. For example, I could tell you that I don't know, maybe this table here will be about sales. Okay, this one is sales. Well, maybe this one would be about, I don't know, the country. Maybe this one would be about the product category, things like this. Category, I don't know how to write. Maybe this one will be about the customer something, I don't know. We've got a lot of tables. The problem here is that if you want to make an analysis, let's take, if I want to make an analysis here from the country, from the sales table, and to know what are the sales by country, I will need to access this table. And to access this table, I will need 1 join, 2 join, 3 joins. Well, in this situation, the country information is actually here in the geographic dimension. What is the main difference between these two ones? Is that for this one, I need to make 3 joins to get the data I need it. Here, I'm up to only 1 join. So actually, this model I give you on the right is called, does someone know it? The name of this schema?
Star schema.
Exactly, the star schema. Star. This is basically a star. You've got something in the middle, and you've got branches. Okay? Yeah.
But don't with the, so you're basically saying that 3 tables, the data has been kind of duplicated in this.
So basically, if we do imagine that the 2 models are kind of the same base data on the origin, yeah, we could imagine together that actually maybe this one, the first one here, maybe it was, I don't know, the name of the city. This was the name of the region or department, and this was the name of the country. So we've got 3 tables. Yeah, actually, we could imagine that this has become this. Exactly. This could be one of the idea.
So there's a huge amount, like if it's a big database, then there's a huge amount of duplication.
Exactly. So in this situation, we could have a lot of duplicated data, of redundancy. So basically, as I explained to you, this is called an OLTP database. Its purpose is to serve the application with a database that is able to handle a lot of microtransactions all over the day, basically. Okay, and here we've got a model that is not about providing a good way to analyze, to provide a way to allow a lot of transactions. We are talking about a database that is able to deliver a good time and a good performance time to analyze the data, to select. So basically, this is for doing updates, insert, delete pretty much often. Here is to do a select statement over a whole bunch of rows. Okay, so by doing so here on the right, we don't avoid redundancy. So basically, the problem in this second model is that we are going to add redundancy that was not here in the first place. But we don't care about this. We actually don't care about this, because what we do want is the fact that in the end, we are able to query the data as fast as possible. Query the data versus modifying the data. So these 2 models don't serve the exact same purpose, not at all. They have different purposes. Okay, so exactly as your classmate told, here maybe in this situation these 3 tables were converted here into 1 table. So yeah, we are going to have a lot of redundancy, but we don't care, because the main purpose here is not to avoid redundancy. It's to make sure the data analysis will be as fast as possible. Do you guys online have questions? Oh, that's good. Okay. So basically, this is called the star schema. Okay, because 1 big table in the middle and tables all around it. The main table, the central one, is called the fact table. What is a fact? A fact is actually an event that you might want to analyze. Okay, so a fact could be a sale, it could be a stock movement, it could be a phone call, it could be a meeting, it could be a lot of things you might want to analyze. But when you want to analyze something, you need to have measure to analyze. So basically, what you will find in the fact table are 2 kinds of data. The first data could be a foreign key. a foreign key that is about linking to another dimension. And the other kind of data you will have is called measure. You might want to analyze measures that you can do sum, average, or anything around it. Okay, so basically in my sales table, maybe I could have 2 measures or maybe 3. I could have, for example, the sales amount, which is a numeric value that I can do a sum, an average, or whatever I want on it. I could have the quantity sold. I could have the margin. I could have a lot of, finally, numeric value. Okay, so here is the 2 kinds of data you can find in it. You can find measures and you can find foreign keys on the other dimensions. Okay, this is how it works. So once you've got this, once you know that the what is inside of a fact table, what is a dimension table? Well, a dimension table is actually a way of analyzing the data. So basically, you can have different ways of analyzing the same data. If I'm asking my business, what is our sales amount in general? I can tell you, okay, we are 3 million of sales amount. Great. But what if I ask you this number by year, for example? So again, if you want to do an analysis over measure, the measure needs to maybe be filtered by some aspect. So if I want to analyze the sales amount, I can analyze the sales amount by maybe by year, maybe by country, maybe by customer. So you might want to analyze data over different analysis axis. This is the term. So basically, a dimension is nothing less than an analysis axis. So I want to analyze this measure over this axis of analysis. So I want to analyze my sales amount by year. I want to analyze my margin by country. Okay, so basically the fact table will contain the measures and the dimension table will contain the way of filtering this analysis, of grouping. So it could be filtering, it could be grouping, it could be different ways of analyzing the same measure. Okay, again, giving just a measure without any filtering could be useless. What is your margin? My margin is, I don't know, 100 million. Okay, but in 2018, oh, this is some maybe more relevant data I can give you. And maybe in 2018 and in France and in a specific city maybe, and maybe for a specific customer. So you see, we can have a lot of analysis. So this is why, again, the fact table will contain the measures that you want to analyze, that you can do a sum over, that you can do an average over, you can do a maximum value over, you can do a lot of mathematical things around it. And the dimension will let you, will give you a way to analyze it from a different perspective. Okay? So this is the star schema. But actually, this is not the only schema you have. This is the base schema. And actually, you've got an extension of the schema. Let's imagine that actually in this table, which is the product table, I would like to have the product, but I do also have product category information. Maybe there are 4 informations about the product category that I group in the same table to avoid joins. Well, actually, what I can do is create a new dimension table that is directly linked to the product, which is here would be the product category table. Okay? So why did I do so? What could be the possible reason to do something like this? You can tell me anything, tell me stupid things, we are going to discuss around them. So what could be the possible advantage of it, of splitting this into another table?
To reduce redundancy.
To
reduce redundancy.
Exactly, to reduce the redundancy, to actually avoid redundancy for this table. This is a good answer. What did you say?
Well, I understood that we'd kind of already, let's say, compromised and said, well, we don't mind redundancy because of the speed. So my idea was like, okay, maybe it's because the product, was it PC, is not always in the product table. So
okay, no. Actually, all the products will be referenced in the product table, but every of them might have a product category associated to it, and for most of them, okay, it will be a not null value, so we will have a product category. So basically, everything was grouped in the same table, and actually, we're going to split this into product and product category. So the good answer was here to avoid redundancy. Okay, so basically, this is kind of weird because I just told you just before, we don't care about redundancy. So why the hell would I do something like this? Well, actually, this is because sometimes it will depend on the situation. So let me give you an example. Let's imagine that, as you may know, when you start a BI project, you will need to understand what is the need of the customer for the company or for who you are working with, okay? And they told you, okay, we have this kind of data, we want to analyze this kind of stuff, and so in the end, you will both decide that there will be, I don't know, 30 reports. In the end, there will be 30 different reports that will be created through SSIS or whatever. And for these reports, if I get back to this, okay, just know that the report here, that will directly connect to the data warehouse. So they will be doing some SQL query to get the data from the data warehouse. So we will have joins, okay? And so when you know this, well, let's imagine that for 2 of the reports, so of the 30 reports you're going to create, only 2 of them are going to be like, okay, we will need to have the product category information. And for the 28 others, we won't need anytime the product category. So first, you know a situation that the product category is not going to be asked this often. So you know that here, yes, when you do so, the advantage is to avoid redundancy. The downside will be, of course, to have more joins to access the data. But the problem here is that actually this table, we're not going to query it this often, only for some specific reports. So first, we know that this will not be a big deal to split it into tables because this second table is not going to be queried too much time. So no need to often do a second join, okay, first. And plus, you know that in the product table, there is actually a very small number of different product category. Maybe you've got, I don't know, 1 million products, but actually, in the end, you only have 4 categories, right? So a big redundancy here. So again, it would be really impactful to separate the 2 because here you would have no name of the product category or no information, just the ID. And here you would only have 4 rows or maybe 5, I don't know, but very small rows. So here we've got a situation where splitting into 2 tables will avoid a lot of redundancy, plus it will be not very impactful for the performance since the second table is not going to be queried that much. Everyone gets it? So in this situation, okay, let's go for it. We can split, this is a good idea. Second situation, on the 30 reports you want to create, maybe 15 or 20 of them are going to somehow query the product category information. Plus, we know that there is 1 million products, but there are actually, I would say, thousands of different product categories. Well, the redundancy is not that big because actually we've got less similar rows, plus the information is going to be asked quite often. In this situation, I would not split. In this situation, I would let it in the same table. So basically, I'm just trying to provide you 2 simple examples when to choose one way of modelizing than the other, okay? So I think you've got the idea now. What is the name of this modelization? When you've got, so I just did this, but just know that I could have done this also, like this. Okay, I can do this over different dimensions. Some will remain the same, some will maybe be splitted. What is the name of this modelization?
Snowflakes.
Yeah, snowflake. So star and snowflake. Okay, so I'm going to just get rid of this. So another good reason that we could need actually to I don't have a big example, but I will try to do this. Let's imagine another example of being a good thing is sometime you could have a new dimension here, and actually a lot of information that is in here could be similar to it. Maybe you could split it, and the two dimensions could be finally using the same information. So I don't know, maybe for example, this could be, I don't know, the name of a company, and this could be the manufacturer, and this could be the supplier. And so actually this would be the name of the company here, okay? So sometimes you could have dimensions that could be shared across the different dimensions. So this could be a situation, or even at different levels, just to be sure. It could be something like this is this, and again a new table here that is linked like this. So here we've got 3 levels, and here we've got 2 levels. So sometimes splitting the tables could lead to less redundancy, because 2 tables could be using the same data in the end. So again, this could be situations, okay? But what you need to know actually for the moment, what you should know actually for the moment is the big difference that there is between an OLTP database and an OLAP one, okay? Plus, know that this is basically the star schema, and this is a snowflake schema. So actually, I think you won't ever meet a star schema, because know that most of the project will have not 4 dimensions, most likely 10, 20, I don't know, it depends on the volumetry, but basically you should encounter a lot of dimensions, and I don't remember a project I worked on with not a single dimension being split into 2 or 3 dimensions, right? So by definition, I would say that the most projects you're going to work with, if not all, is going to be about a snowflake modelization, right? For this reason. So know also that you can have this. Know that you can also have fact table. We could have dimensions like this. And this is a sales. Okay, so this is sales. But you could also have another fact table in the same data warehouse, which this one would be about stock movement. Okay, so these 2 tables contains facts. So basically, this one is about analyzing the sales, and this one would be analyzing the stock movements. So again, this is a fact table. Well, and maybe even, I don't know, another table, I don't even know what it is about, but this is also a fact table. Well, I could have this. This one, this one. You see, we could have multiple fact tables in the same data warehouse. This is totally possible. I've worked on projects with a lot of data with only 1 fact table, and I work on projects with not that much of data, but a bunch of fact tables, because they want to analyze different things. So it will depend strictly on the project. Well, in this situation, we've got multiple fact tables that are linked with dimensions. What do you think would be the name of this modelization? Now we have, what do we have actually? What do we have multiple? Fact. So we have multiple. Fact. So we have multiple If you've got multiple fact table, you've got multiple. No. No, multiple stars. We've got multiple stars here. So not multi-star. This is not. I don't think this is a real world. A real world. Not galaxy, but almost. No. Stay on the space aspect. When you look at the sky. Constellation. Okay. So this is just some terminology thing. Okay. But here is the fact that when you've got multiple fact tables, because they are linked together, we talk about stars being linked together. So we talk about a constellation because they are linked together, basically. Okay. So this is just some terminology here. Okay. So this is constellation. 2L, I guess, constellation. Okay. So this is just some terminology, but just know that you can have this situation. So maybe you may want to take a break now. Okay.
Just a question first. So with OLAP systems, is it normal for this data to be, let's say, like indefinite in the time period? Like for every transactional database, there's kind of like the same but bigger for the OLAP system, or is it like, okay, I want to have this OLAP system which covers the last year?
Okay, so good question. Actually, this is a subject we will discuss further a bit after. A data warehouse has some kind of I would say hierarchical, historical duty in a way that whatever gets into the data warehouse should not leave it. So basically, let's imagine two situations. Let's imagine a situation where every time you've got the sources with the sales, etc., that contains the total historical data that the company ever had, and you just want to every time increment this and just add it to the data warehouse, what was not in the data warehouse to be added, right? So in this situation, you've got sources with all the historical data, so you might just simply, for the fact table, just empty it, so truncate, and just put the whole new data. This is something you can do. Other situation, imagine that the data comes from Excel file or database that only contains the last 3 months, for example. Well, in this situation, you won't get rid of the data that was previous to this in your data warehouse. So if you've got data since, I don't know, 2010 in your data warehouse, you are not going to say, okay, I get rid of this, I just get the 3 previous months. Because even though you're not going to make actually analysis over it, you're not going to do analysis for the last 10 months, 10 years, for example, where you could actually use this historical data for some maybe further analysis, and would say maybe future analysis. Like, for example, you could do something like this. I don't know the term in English, but this is called, in French, this is régression linéaire. So I think this is linear regression, I think.
Linear regression.
Yeah, so basically you could do something like, okay, today we are in 2020, and I've got data since 2010. So for this specific product, which is named ABC, and for the month of February, for example, I want to know the sales. So basically, I'm just going to use the data from my data warehouse. So it was here at some time, then here, then here, here, here. Well, okay, this is too easy. Let's say like this, maybe like this, and maybe like this. I don't know. And so I'm trying to do something. I might be able to do something. Maybe like, I don't know. Maybe something like this. I think I'm pretty correct here. So thanks to this linear regression, I think that we can forecast and think that for February 2021, based on this data, I could imagine this. But you see, so this is not because you're not going to do an analysis specifically 10 years ago that you won't be using this data. So this could be one of the many cases you could use very historical data. So to answer your question, you don't get rid of what was before.
So really, all of the stuff about being sensible and not duplicating data and database design,
we don't care about this.
It's all just about being able to manage a large amount of transactions.
The purpose of an OLAP database is not to provide a good way to do a lot of transactions. We don't care about this. The purpose is to make the analysis as fast as possible. And so the modelization we will use will help in this behavior. So we are just trying to make sure that the analysis will be as fast as possible. So analysis is like select. Transaction is like insert, update, delete. One way we try to serve the transaction, the other way we try to serve the select. Okay? That's good. So basically, this is why one of the reasons you would not like to get rid of your, you don't want to get rid of the historical data. You will get everything. And we will discuss later in the course that actually these dimensions here are going to be going to contain historical data, even though you only have the data that comes from the source. Even though this data is going to be data from the last year, okay, and that you don't have products that existed 3 years before, you still are going to keep this product in your dimension table, because your fact table might still have transactions, sales or whatever, that depends on this product. And you need to make sure that there is still a link between a sale and the product that is that is involved in the sale. Okay, so you won't ever get rid of historical data, of course, except if the projects is needed to. Okay, but actually in BI you don't get rid of historical data. You keep it because it might help you sometime later. Okay, and basically we don't care about the storage thing. I mean, 15 years ago, it could have been a problem, and so we use some other ways. I mean that maybe the Snowflake modelization was maybe more of, I didn't used to do so. I only do BI for like now 6 years, I guess, so I was not here 15 years ago. But I think for some logical, physical, and cost problems, it would be like, okay, sometimes we cannot afford to have too much redundancy, so we need to, by force, we need to go for the Snowflake. Nowadays, with the storage efficiency, the low cost, etc., I don't think this is something that is too common. Okay, so as far as we can go with the star schema, we stick to it. But basically, sometimes you can have maybe 10 dimensions, maybe 20 dimensions, and one of them is going to be maybe what we will call a snowflake dimension. That is a dimension that has been snowflaked, if we can say so. Okay, so again, this is a situational aspect. You can say this time you do so, and this time you do so. Okay, so take a 15-minute break, okay, and we get back to it just after. Whoop.
OT. You say na alumni tell you about this. Which alumni tell you about this?
Don't be alumni with the most information.
Which alumni?
I don't know.
And Peter. And from Peter,
Some of the time don't run alumni. Peter know your life. We now consider work with this guy. The guy that works with this data. Okay, now get back. Hello, Baba. Hello. Yeah, how you doing, Baba? Yeah, I know. Yeah, it's a good news. Yeah, that's great. That's good. Yeah, good though. Be offset. Offset. Amen. Amen. You don't reach out by April, I'm starting my children. Starting 95. I'll be thinking about it. Once it starts again. I don't get on. You dress formally, you're going to work. It's not IT. They don't call it IT. It's internship. It's a proper work. You're doing a proper work. You're going as it's just like a way of evaluating. If you work, if they enjoy the way you work, they will take you. And so you dress as official as they dress there. You dress as. You're not wearing what do you call official is a function of how you dress. Nobody wears suit and tie, blah, blah, blah. Nobody does that anywhere again. But at least you see a pay formal. It's once if you are going, you wear one shirt and you are doing fly polo.
Okay, so let's get back, everyone. So to keep going on the same subject about the store schema, I would like just to put some focus on one specific thing, is the fact that you've got in every single data warehouse, you will have fact tables and dimension tables, but more specifically, you will have every time a date table. So the date table is a table that will contain actually a lot of rows, actually one row by day. So every single day will be referenced in this table. So of course, this is not going to have the whole day, the full days of humanity, but actually the context that is needed. So basically, if we've got data from, I don't know, from 2012 until today, maybe we're gonna have a day table that will be maybe 1 year earlier than the lowest day value, and maybe 1 year after the highest. Okay, but we need to have every single possible date contained in this table. So we're gonna have one row by day, and the most important thing here is that we're gonna have the columns of this table that will be actually a splitting of every single possible value of the date. So we might have a column with the year, a column with the month, a column with the month name, a column with the day, a column with the day name, etc., etc. So we will have very various columns for one specific date. My question is, actually, we could totally get rid of this table, because in the sales table, I could have a simple field with a date inside of it, telling you, okay, this sale occurred on the 12th of February, for example, and 2017. And based on this date, you should, guys, be able to translate this date to get, for example, the month of the date or the year of the date. For example, in SQL, you've got functions such as year, month that gets you a specific value for a specific date. So basically, you would be able to split this with SQL. So what do you think is the possible reason why we actually have this table that is generated at the beginning of the project and that will contain every single date? Why do we finally force ourselves to have this table where we could totally make analysis without this table by just doing some functions? What do you guys think is the reason why we force ourselves to always have this date table? I tell you for sure, I don't know any single database data warehouse project where we don't have this date table. Every time it's present. So why? Think about the purpose of the data warehouse, the purpose of this modelization, and what do you think could be the reason we finally just use this date table every time? We don't forget about it. We always get this date table.
Is it to force all of the different tables and stuff to be related to the same type of date? So for example, you may have like date time by seconds or milliseconds in.
Okay, let's get on point the fact that this table doesn't contain any time value. This is only going to be date, day, month, year. Okay, only this. Of course, you could have a context where you would like to know about the minute. Sometimes it can happen, but it will be a very specific situation. And we would maybe put the time in one other table to have no redundancy, because if you do so, you would have a lot of redundancy date. So here we just have months, day, month, year. So basically, why would you not just do this by SQL and just instead create a dedicated table for this?
So I think you can actually do some drilling down using your date parameters. You could drill down by quarter, you could drill down by maybe day of the week, you could drill down by months or whatever. It gives you that flexibility of drilling down to your data.
So you talk about drilling down. So drilling down is a term we didn't discuss yet. The drilling down is actually being able to get down into more detail of certain dimensions. So for example, I can drill from the country, I could drill down to the region or maybe to the city, so something like this. But actually this is not the reason, because again, if I've got a fact table with a full date, if I want to make an analysis on the day, for example, I could just use the SQL function day over the date, and I will get the day. And if I want to go even more precise, like for example the semester, the quarter or whatever, I have always a SQL function that would be able to give me this information. So again, so now I'm going to answer. The reason behind this is because basically, if we do this by using SQL, we're going to take more time than doing this by checking the data that is actually already in the date table. Because as you may have understood now, the date table will contain every single possible date that is relevant to my data warehouse. And for every single row of date, I will have the split of everything. I will have the splitting like the day, the month name, the year, the quarter, the semester, whatever I need, okay? Even the day name, Wednesday, Tuesday, Monday, Thursday, every single information that might be relevant to my analysis will be already created in this date table. So basically, the date table will let you make time analysis faster than by using the SQL function. Why? Because actually, if you do use a SQL function, you will have to apply this function on every single row. And you should know that a fact table is for sure a table with a lot of rows in it, millions, maybe tens of millions. So again, it could have a lot of rows. If you apply on just one column, one function that will split the data for one single date and to months and year, for example, it will take some time, not minutes, but at least some time. Whereas just doing one simple join with the date table will be much easier, because in the date table, every calculation I need is already done. So I don't have to recalculate for every single row. I just have to do a join on the foreign key and the primary key, and that's it. So the reason we always have a date table in my model is only to improve, again, performances on the query thing. It's to say that OLAP is to improve times of query, the times of retrieving data. So by doing so, we have a table that already contains every single date that might be relevant to my interest, to my data warehouse. Again, this is the upside. But what is finally the downside, the drawbacks of having this table? Well, we could say that having this table already generated will just generate more data, because we are generating every date and we are storing them, whereas we could be finally calculating them on the go. So basically, we are storing data that seems to be not necessary, but actually it's pretty much nothing, because for 1 year of data, we only have 365 rows. So even if we have a 10-year history, we only have 3,060 and 600 rows in my data warehouse. So again, this is not going to be something that is going to wait too much for my database. This is going to be a really small table compared to a fact table that is about millions, tens of millions of rows. So again, the impact of having this small volumetry here compared to the other tables, specifically the fact table, is nothing. So again, keep in mind that every single database, so data warehouse model should be with a date table every time. There is no situation I know where you get rid of it. The only possible situation would be if in your data warehouse you had fact tables that are never related to dates. I don't think it exists, because every time, if maybe you don't have only one table of fact, but maybe multiple fact tables, at least one of them will always have a date association to something. So actually, I don't remember any project I worked on where you don't have the date. I mean, a sales is related to a date, a phone call will be related to a date, a meeting is related to a date. I mean, any single event, I can't possibly imagine right now an event without a date. I'm sure it exists somehow, but I mean, I don't remember any project without any single date reference. So that's why you finally create a date dimension to go further and to go faster in your data analysis. Any question about this, or that clear? Everyone good?
I guess so if it were, let's say, something about time, you would have the date, then you would have the timetable separately.
So if we got the time, I actually didn't encounter this situation, but yeah, in this situation, we would like, I think, to at least not put the time in the date, because otherwise, yeah, for one day, you've got 24 hours, and 24 hours, we've got 60 minutes. So you would have to multiply the number of rows each day by minutes, by hours, minutes, and seconds. That would be, yeah, it would be huge. So I think if you really need to analyze over the time, maybe, I don't have this situation actually, I didn't have it, but I think this is something that's possible. Either do you create a dedicated table for this, or maybe do you put the time directly in the fact table. Maybe you want to split it already. You want to maybe say, okay, I've got the hour and the minute, because maybe you don't care about the seconds. So it depends on the situation. But most, if not all, of the BI projects will always use a date table anywhere, anytime. Okay? So are we good with this? So we discussed about everything here. So
just to add to what you said now.
Tell me.
I said just to add to what you said now. For a situation where maybe you need to retrieve time, most times you just join on the dates table that you have, and the dates column in that particular table where you want to retrieve time, and then you return just the time component of it. So most times it's usually a join on dates, but you can retrieve time as a separate column. So that you can have basically for analysis and for performance. Most times, having a separate table for time is not usually feasible because of the extreme, the data impact that might possess on a data warehouse.
Actually, I'm not sure I quite understand everything, but you tell me that you seem to have an experience with time problematic, right?
Yes.
Yeah. So basically, what do you recommend? Do you say that you seem to say that we don't create a timetable, right? That's what you say.
Yes. Yes.
Yeah. And so, how do you get the data for the time in this case?
What I'm saying is, since there's usually a date table, which has all the different dimensions of this, and for the table, either a dimension table or a fact table, most times for fact tables, you usually have date time. So most times it's like a convert on the date part of that table, joining with the date table, and you can always retrieve the time component of that column in a separate column. So it's not that
you mean in the columns of the date table?
No, in the columns of the querying table.
The fact table.
Yes.
Yeah. So that's why. Yeah. Okay. So that's why I say in this situation, I don't think you would create. I think some situation could be maybe relevant to create a timetable, I guess. But I think most of the time, for the time information, I think you would have, as you said, maybe I think 3 columns would be fine. Like in the fact table, you would have 3 more columns with hour of the time, minute of the time, and second of the time. And in this situation, every information will be relevant to only one row of the fact table. So that's why I said actually, yeah, I think that I'm not sure you're going to every time create a timetable, even though I think some situation might require to have a timetable, because sometimes it could be relevant to make calculations on the go, not make calculations on the go, but have them already created in advance. So as you say, I think that the most situation should be about having the time columns directly in the fact table. That's what you said?
Yes, yes, yes.
Okay, great.
Okay. Perspective.
Okay, so now that we are good with this, so as you know, this afternoon we will start to use the ETL. So I'm going to do some examples with you. I'm not sure I'm going to use this, but maybe my own PC. So that's why I'm going to ask if I got something to do, but we will see after. So anyway, what you need to know before we go in is, I think I might remember one of the subjects after, but before we start this afternoon, I would like you guys to quickly understand how we actually are going to get data into the data warehouse. So basically, we will have my sources. So I will provide you some. So basically, we are only going to work with Excel files and CSV files, okay, for some reasons. But we could totally use databases, okay? But at the moment, we would only use files. So we might have, for example, this is not what we are going to do, but we could have Excel files, CSV files. We could have a database with tables that we might use, okay? So like this, different tables maybe, like this. Okay, so this could be the sources we want to use for our business analysis. So basically, it doesn't mean that the source database only has 2 tables. It means that we want to retrieve only 2 tables from this table, okay, from this database. So we are working this way. We will be working this way. We will have the star. We will have the ODS. And we will have the DWH, okay? So you know, but we will discuss this later. STAR, or sometimes STG, stands for staging area. ODS will stand for operational data store. So honestly, for the operational data store, I don't really know why this is named this way, but actually this is the name that is mostly used in different projects. Yeah? No? Okay. So star, ODS, and DWH for data warehouse. So basically, this is going to be your main data warehouse with your dimensions here. Okay? So when you start a project, you need to know what are the sources you're going to use, what do you want to do with this data, and so based on what you need to do in the data you have, you need to design the data warehouse before going further. Okay, so this should be the first step you have, is to design the data warehouse we're going to use. So fact table and the dimension table. So we want to get from this to this. Okay, so we are not going to go straight away and like, okay, we just insert everything and that's it. No, we're going through different steps. The first step will be to go through the star. So the staging area. Basically, this is something very simple that we are going to do actually during the TP. One source equals one table. That's simple like this. We've got one source. We will insert all of this data into one table. One source equals one table. I've got 16 sources that I want to get data from. I will have 16 tables in my staging area, basically. Okay? This is the first step. Why do we do so? For multiple reasons. First, we want to extract the data. So this is basically the extract operation here. We want to extract data as fast as possible because maybe, for example, these 2 first files are located in Paris, in a server in Paris. maybe the database, the second one is based on San Francisco, and maybe the last one is on Tokyo. So maybe we've got different cities, so different servers, so different geographical location. And if you want to cross the data together, you won't have to deal with, network times, etc. So basically, you just first want to extract everything and put it on the same place, which is the same server. This is going to be a dedicated database, which will be named STA, or staging area. So first, we extract everything. Something that is really important, and we will know why after, is that even though, so we are going to first extract an employee's file, okay? So from this employee's file, we will have, for example, the birth date, the salary, etc. We won't assume that the salary is for sure a numeric value. We won't assume that for sure the birth date is a date. We don't care about this. We will not care about this. We will say everything that gets into this star table, this staging table, will be of type varchar. So varchar is varchar, okay? This is a dynamic value, different dynamic length of the text value, okay? And so here we won't care about the type because we cannot trust the source, even if the source, except of course if the source is a table, because in the table you do have types that will be respected no matter what. But because we're only going to work with Excel files and CSV, we won't trust the source. Even if the source tells us, hey, trust me, this is a date. No, I don't trust you. I will put everything in varchar, and then I will check myself later if this is actually a date or not. There could be some errors. This is something that can happen, okay? So we won't trust the source. We just say everything in varchar. Why varchar? Because, and varchar 255, to be sure that we can get everything. Why? Because we will check this later, okay? And so a varchar can accept anything. A text field can accept anything, whereas an integer field or a date field won't accept everything, okay? So we don't care about this. Then we will have this. Maybe this file will become this. Maybe this file will become this. So we will have maybe one ODS table for this data, or maybe even, maybe we have a lot of modifications to do, and maybe we will go through 2 different steps. So maybe it will be just 1 step, maybe it will be 2 steps. We might go through different stages of the same table, okay? Transformations can be of very, very different kinds. So I'm not going to explain everything, but just know we can go through different stages. For our exercises, we will go only with 1 stage every time. Yeah? Operational data store. I don't really understand why this is called this way, because I think this is a historical thing. But actually, in the project I used to work on, you need to know that we call this the ODS. Sometimes we call it the SAS, SAS, not an acronym, just saying a SAS before getting into the data warehouse. You know what a SAS is in English? No, I don't know. A SAS, like before getting into, you go through maybe in case I don't know, in case of pandemic or something like this, and you want to enter some safe space, you need to first enter a SAS, get decontaminated. So I don't know what I thought this was a word in English. This is some pre-entering zone. Okay, so I will get the definition maybe. Let me one.
Statistical analysis system.
No. This is more like a day-to-day entry lock. Entry lock. This is the definition I got.
SAS.
SAS, yeah. Like the only main. I'm trying to find the. Actually, this